I'm David Saffer. I'm a photographer. I work just outside of Los Angeles, California. I used to live in New York, which hopefully gives me a couple of points here. I'm also a printmaker. I'm a fine art printmaker. I make prints for other photographers. Most of my fine art work is in landscape. A lot of my, say, photography for a living is product photography and commercial photography, catalogs, websites, trade show displays. I've done a fair amount of that sort of thing. I shoot with a Hasselblad and a Nikon. I also have a couple of smaller cameras. This is a photograph that I took in Washington State. It's in an area called the Palouse. And although this screen doesn't do that great a job simply because the lights are shining on, if you look at one of these monitors, you can see that there's really, really good differentiation in the greens, for one thing. And there's also very good differentiation in terms of highlight, shadow, and mid-tone transitions. And that's the sort of thing that you're shooting for when you're engaged in good color management. If this was poor color management, that could just as well be a green blob with a tractor on it. So the idea in color management is to really get the definition and the details and the nuance in every photograph that you take to really come to life. And if you're not getting that out of your images, then you need to do more. Because nowadays the gear that we have, the cameras and the display equipment and the printing equipment are so good that you should be able to do that with just a little bit of discipline and work. So the big picture, what's color management? It's the ability to efficiently, I'm going to read this because it's important to get it verbatim, the ability to efficiently reproduce consistent, predictable, and repeatable color across a range of devices. And that really means end to end. Start with the camera, and we end with the display device, whether it's a display like this or a printer, and it really doesn't matter which type of printer, but we're going to be talking primarily about RGB printing devices like the Epson and Canon machines that are so commonly used today. A calibrated workflow is always more efficient and predictable. What happens a lot with people, and I get this question all the time, why doesn't my color look right? And I ask that person a few questions, and I usually find out 8 times out of 10 that the print is actually too dark. The color's fine, but the print is too dark. And the reason the print is too dark is real simple. The display's too bright. Crazy thing. So people are noodling around and struggling, and I'll get an email or a phone call, desperation, I'm ready to throw the thing out the window into the water, and I go, just calibrate your display and get the brightness down, and it will match your prints. So some of these things that seem really difficult and really uphill all the way are actually very straightforward if you're methodical, if you go from A to B to C to D. And you can see here, it's capture to image processing to display to processing and post-production in your output device. You have to control it every step of the way. Now, sounds complicated, doesn't it? It's not complicated. It's just methodical. Once you get your color locked down, you're going to find you're going to spend less time and less money and get better results. I guarantee it. And I have a lot of people tell me, oh, it's just, there's so much to learn and all this other stuff. But if you just go into it step by step and follow the instructions, I kid you not, at the end of the day, you're going to find you're going to spend less time sitting behind your computer screen and more time behind your camera. So some of the things we're going to talk about, get it right in the camera. You want to work on exposure and dynamic range. Nothing will kill contrast and color more or faster than a bad exposure. So we want to talk about that. We also want to talk about calibrating your camera. We're also going to talk about improving the performance of the LCD on the back of your camera, not just in terms of the histogram, but in terms of how it looks to you when you're doing your doing the chimping thing. We want to manage that display. It doesn't really matter unless you have a display that can't be calibrated. You can always improve the color that you see on the screen, and not just the color, but the highlight and shadow detail, and particularly in the highlights. We'll talk about that a little bit later. The highlights are the first thing to go. If you take it out of the box and it's not calibrated, the highlights are almost always going to be bad. And I'll explain a little bit more about that in a little while. When you're editing your images, you really want to be editing to your endpoint. In other words, you're editing the color and actually editing in real time. So what you see on the screen is actually what you're going to get when you're finished. You're not going to have to guess. You're not going to have to make a print and then tweak it and go back to the screen and tweak that image and print it again, and then go back to the screen and tweak it. What you're going to do is print, let it dry, and frame it. No more proof prints, except in a couple of exceptions. So let's talk about the camera. Everybody here owns a camera, right? And a lot of you own multiple lenses, more than one lens. And one of the things that does happen is that each camera body, the sensor and the lens in combination create a color signature. It's what I call a color signature. That color signature is different. Even if you've got the same camera body and you put a different lens on it, that color signature is going to change in some degree. Lenses have different numbers of elements in them, different coating, C-O-A-T, coating schemas in them. And so the color may be slightly different, particularly between a telephoto lens and a wide-angle lens, for example. And so there are ways to control and compensate for that. You can enhance your exposure performance. We have tools that we're going to show you that help you control exposure in addition to the meter that's in your camera. You can do in-camera white balance. You can use the white balance tools that are on your camera, or you can do a custom white balance. The custom white balance is always going to be more accurate, and we're going to show you why. And the camera calibration really does give you a bump in color performance, excuse me. So we're going to talk about one widget that we have. This is called a spider cube. The spider cube, a lot of people have said to me, wasn't this just a gray card? And the answer is no. One of the reasons that it's different is that it actually has a shape. It's not flat. So I'm sure you can see if I hold this up that one side is brighter than the other. Okay, so it gives you an idea of which side is the primary light side and which side is not, typically speaking, if I move around. You can see that the light will change as it falls on the cube. It has two gray surfaces. They're neutral gray. Two white surfaces, a black plane, and an absolute black or a black trap. So, and I'll explain this a little bit more in a moment. It has a ball on the top for showing you specular highlights, a little hanger cord, and on the bottom it has a standard tripod mount, so this can be mounted on a tripod or an appropriate light stand. Tell you what I'll do. I'm not going to pass a lot of stuff around, but I'll pass this. Now, it's made out of advanced polymer. If it gets dirty, you can wash it off. You can take a little scrubby and scrub it off. It's the same color all the way through, unlike a lot of things that you'll get. I think if you ran it over a car, it wouldn't hurt it. With a car, it wouldn't hurt it. It's really durable. It's very, very strong material. And it's the same color all the way through. We use it for exposure management, for in-camera white balance, for post-production and color and gray balance. We use it for helping us set dynamic range. And it's useful in handheld and tethered shooting and in post-production. Let's talk a little bit about the LCD that's on the back of your camera. We all know that you can see a preview. See a preview on the back of your camera. You take a picture, and you can look at it. And you say, well, I don't know, this might be a little bit too hot, it might be a little too cool, it might be, the color might look a little bit funny, but the fact is that whatever you're looking at is a preview of a JPEG. How many people here shoot RAW nowadays? Everybody. But the camera is telling you a little bit of a fib. The camera is showing you a JPEG. Now, why is that important? Well, if it's showing you a JPEG, what has it done? It's processed it in the camera, it's compressed it, and it's clipped the color, and it's clipped the dynamic range, in part because the LCD on the back is nowhere near as capable as a display on your laptop or your desktop. But it's showing you the histogram, and it's showing you a view of your shot as a highly processed JPEG. Now, what's wrong with that? Well, it's basing its calculations in part on the white balance that the camera is generating. Now, you may be on auto white balance, okay? Or you may be on what's called custom white balance, which are these, and this is from the Nikon instruction manual, but you also see this in the Canon instruction manual, et cetera. You can see it says incandescent, flash, direct sunlight, cloudy, shade, or choose a color temperature, but you can see that all of these are whole numbers. 3,000, 5,400, 5,200, 6,000. Those are all approximations. Now, does anybody here believe that every time you go out on a cloudy day that it's going to be 6,000 degrees Kelvin exactly? It's not. So the camera is in the ballpark. So now you've got two things going against you as far as what you see on that screen. You've got the fact that the camera is guessing at what the actual color temperature is, and you're looking at a processed JPEG. Well, why not fix that? I need the spider cube back just for a second. Who's got it? Spider cube. Who's got the spider cube? Where is it? Okay. So, can I borrow your camera? All you do with the spider cube is you hold it up, you take a picture of it with the gray and the white areas facing the camera, okay? And it's not actually a picture. You use the white balance button on the back of the camera. You can see here, you hold that, you push that down, and then you press the shutter button, and it sets the white balance automatically in the camera for your lighting condition at that time. Now what's happening? Now the camera knows exactly what the white balance is for that lighting condition, that time of day, that place, or in the studio, et cetera, et cetera. And then, can you hand this back to the person who had it, please? At that point, then, your histogram, it's still going to generate a JPEG for you to look at, but your histogram is going to be more accurate because it's based on the exact color balance. It's based on, real world. And you're also going to see a better view of your picture, particularly when it comes to the blinkies, not particularly, but in one way, the blinkies on the back. You know how the white areas blink when it's overexposed? Okay, so everything about this LCD is going to be more accurate. The white blinkies are going to, if they're running, they're going to show you which areas are overexposed. You need to adjust your exposure. You should see a blinky on top of the specular ball, the specular highlight. You should see one up there. You should, if your exposure is correct, you will not see the white areas blinking. And in the black area, where the black trap is, that black circle, if you can't see the black circle, generally speaking, you're underexposed. So now you have two choices. You can go to manual exposure or exposure compensation, at least two choices. You can go to one of those and adjust your exposure and then take another shot of the spider cube and see whether or not that has improved things. Does that make sense? I think I might have confused it a little bit. You do your white balance in the camera, and then you take a shot of the spider cube. Then you look at it on the LCD screen. You're looking for blinkies. You're looking for a disappearing black circle. It's going to tell you whether your exposure is correct or not. Now, you can use manual exposure, or you can use exposure compensation to fine-tune. Now, I do want to remind you that it's set for that lighting condition, so that white balance is not a permanent thing. It's not going to last beyond, let's say, somebody moving a light or introducing a new light or turning one on in a room, or if you go from sunny to a shady condition, you're going to want to do that over again. But it's particularly useful indoors in mixed lighting situations like you'd see out here in this room. That's what I call a mixed lighting situation. There's hundreds of light sources out there. A lot of those tubes are different age, and so the color temperature is going to be a mixed bag, to say the least. Now, this is a photo shoot that I did for a semiconductor company. This is a semiconductor oven. Lighting was very difficult. This is on the shop, actually on the shop floor in a separate clean room that they set up for their customers to view their product. And I did not have complete control over the lighting setup, in part because it is a clean room and I can only take so many things in there. So I had to use some of their lighting and some of mine. So I used the spider cube, and you can see the original shot looks pretty blue. Can you tell that on this projector screen? It's probably a little more obvious over here. Okay, and then once it's corrected with the spider cube, it's much more neutral. It's still pretty blue because a lot of the lights in that room are very intense and hard to control, but it's not as bad as that on my computer display either. So how many people here are accustomed to neutralizing color in their software application in post-production. In other words, using the gray eyedropper. Just a few. Okay, this is just one application. If you're working with Lightroom or you're working with Photoshop, this is phase 1, capture 1. I'm going to use the cursor to show you where this is. Right up here, there's an eyedropper, and if I click on that, I can come over here to the photograph and click on the gray face of the spider cube. And when I do that, it's going to neutralize the color in the image. Now, it's built to do that. Now, you can also notice that on the spider cube, I'm using the brighter side of the cube to do this. The reason is that that's my primary light source. The brighter side of the cube is showing me where most of the light is coming from in the shot. Does that make sense? So I'm using that side of the cube to neutralize the color in the image. Now, are there any people here? I'm going to go to Photoshop and show you a similar thing and elaborate on this a little bit. You can use it to just neutralize color with a gray eyedropper, or you can actually control your dynamic range by setting your white and your black point. Is that something any of you are familiar with? Okay, good. So in Photoshop, for example, if you open the curves dialog and you have 3 eyedroppers there, you can see with the red outline, you have the white, black, and gray eyedroppers. And you can go to the spider cube and you can set your white point, your black point, and then I recommend you do your gray point third, and set the ends of your dynamic range in your photograph and then neutralize your color. Now, there's an issue with that a lot of people don't know that I'm going to talk about for a moment, which is that those eyedroppers are set to a specific RGB value. So the brightest eyedropper, the white eyedropper, is set to an RGB value of 255 across the board for red, green, and blue. That's a little bit too bright if you're going to be printing. That's going to give you some washed out highlights in a lot of cases, and it's going to show paper white a little bit too early. What you really want to do is to control that and set those values down to around 245 each. So how do you do that? To get this dialog, you double click on the white eyedropper and this dialog will pop up. Now what you do is take your cursor and you click in each one of those boxes and you just type in directly 245 for each one of them. And you click OK. And when you click OK, you'll get another dialog that says, are you sure you want to do this and set this value for your white eyedropper? The answer is yes. Okay. Then you're going to go over to the black eyedropper. You're going to double click on that. And you're going to see 000, which is absolute black. That's the value of the black trap. That's too dark. That's going to kill a lot of your shadow detail. So what you want to do is instead is type in a value somewhere between 5 and 9. I typically put a 7 in there. And put 7, 7, and 7. And click OK, and then yes. Now, this may be a little bit confusing, but keep in mind we're recording this, so you'll be able to go back to this on the B&H website and take a look. Now that you've done that, when you set your black and white points, you're going to have dynamic range that's within the scope of the printer that you're going to be using in most cases. If you're using a decent 6 to 8 to maybe even 12 color printer, that printer is generally going to have a dynamic range that will capture that low point and high point. Here's another example of color correction. This is a bowl that I shot for a catalog. And you can see on the upper left, I was using a gel that was just a little bit too magenta. And so rather than go back and reshoot it, I simply neutralized the color in Photoshop. This is probably a better example. I neutralized the color in Photoshop and got a good result. Now, this is a device called the Spider Checker. It's a very, very useful color management tool. You can use the Spider Cube and the Spider Checker together. In fact, there is a reverse mount right here on the top, so you can screw the Spider Checker on top of it. There are, just to read this, which I don't normally like to do, there's 24 patches on the right side that are more or less within the sRGB color space. Is everybody here familiar with what that means? There's several color spaces. One is sRGB, for example, the newer Apple laptops, the display is showing you a range of color that's characterized, that gets given the name sRGB. It's a little bit more limited than some of the wide gamut displays that you see, which are typically Adobe 98 RGB. And most of the good or the better, the higher end printers that are being produced by companies like Epson and Canon and HP nowadays are close to the Adobe 98 color space. So if you've got an 8, for example, an 8 ink printer or a 12 ink printer, those are getting up there in terms of the gamut or the number of crayons in the box, the color space that you're getting. There's 6 additional skin tones, and there's 6 medium saturation colors, and there's a gray ramp increased in 10% steps, plus an extra 5 and 95% gray sample. Now, this is used with data color software to create a calibration of your camera. Now, what's that calibration mean? What that really means is bringing the color back to a known state. So white is really white, gray is really gray. It doesn't have a color cast like pink or magenta. The skin tones look natural. Things that are benchmarks like the color of the sky and the color of the ocean look natural and clean and really lifelike. So what one does is you take a photograph of this with your camera, you more or less fill the frame with it, and you have to be careful with the lighting with this, because what you don't want to do is you don't want to tilt it so that there's an area that has a reflection or an area that, for example, is in shadow. You want it to be flat lighting, and you want it to be parallel to the sensor plane of the camera. So you want to have it, say if it's at this angle, you want the camera to match. You want it to be as close as possible to vertical, and the camera the same. And if they're tilted, then tilt them in sync. And then what one does is you import this into our application on the computer. You crop it to fit into a line, and if you look at the screen, you can see these handles. I have to get behind the computer. You can see these handles, and you can pull these back and forth, and you can move this around so that it's square inside the frame in the software. You also want to make sure that these colored squares are centered and aligned. You don't want to have them be off-center, pushed to the top or bottom. And what does happen occasionally is some people will shoot this upside down. You want to make sure that it's right side up, that this color is on the top left, okay? And this color is on the bottom right. Sometimes people shoot it upside down. It won't work. Sorry. And then what you do is you can save the output to Lightroom. It'll go directly to Lightroom as a preset. You can save it to Adobe Camera Raw, and then you can apply it to the pictures that you took in that lighting setup, and it will correct the color for you. It's very, very useful. It's a step beyond what the Spider Cube will do, or setting the white balance in your camera. Is it a night and day difference? No, it's a level of precision that you can't get any other way. Now the opposite side, you know, I want to point out a couple of other things about this. One of the interesting things about this is that there is a space here called the fade checker. Now, what the heck does that really mean? What it means is that underneath this bevel, which is held by a magnet, you can see that there's 2 of these squares. One is always covered up by the bezel. So over time, these patches will fade. It takes a while, and it depends on how much light exposure they get. But they are pigments, and one of these patches will fade. Over time, as you work with this, it's a good idea to occasionally open this up and check and make sure they match. When they don't match, it's time to replace these panels. Now, it's much less expensive to replace a panel or 2 than it is to replace the whole device. And on the reverse side, we have, now it's the same gray steps that you have on the other side, and nice neutral gray patches. You can also use this to set the white balance in the camera. Some people use these for video cameras. Okay. And the large gray patches are set to the 50% gray level. Let me think about this. I just also want to remind you that, like the other side, you do want to check for evenness of illumination. You really don't want this to be unevenly lit. You don't want to have any reflected highlights or anything like that that will throw things off. It's more important on the color side, but it's important on this side too. So it's a little bit technique dependent, not overly so. It's not a burden or anything, but it's a good idea to keep those things in mind. Now, display calibration. How many people here do their image editing primarily on a laptop? Okay. And on a desktop would be the rest of you? And I see hands? Yep. And how many of you have a display that you purchased, say, within the last couple of years? Okay, good. The more recently you've purchased a display, generally speaking, the more likely it is to be a more capable display than the kinds we had in the past. It used to be when LCDs came out that they were burdened by a very limited color gamut, and there was only so much you could do to really get color fidelity out of the device. Nowadays, that's not the case. The displays are much, much better than they used to. I mean, look at this. This is a television set, for God's sake. Look at the color. It's amazing. And so it's more important than ever to calibrate your display. How many people here actually do that? So probably not enough. Some of the biggest reasons is my prints look too dark, right? But you also want to be editing your color in a way that what you see is not only what you're getting at the moment, but what you're going to get down the road. And again, I'm going to show you how to use some of these color management tools in a very proactive way that will govern exactly what you get when you make a print, whether you're making that print yourself or you're sending it to a print service provider. Now, this is the Spider 4 Elite. It's a very distinctive design. I'm sure a lot of you have seen this. And the fundamentals behind how this works is that the software is going to show a series of color patches on the screen, and there is a multi-level sensor inside the device that's going to read those color patches. The software is going to compare what it sees to what it's supposed to see. It's going to measure the difference and save that difference. And it's going to adjust the color in your display so that it's delivering to standard. That red is going to be the correct red, the correct green is going to be the correct green, that the brightness level is going to be such that your highlights that you work so hard to capture in your photograph are going to be there, and your shadow detail is going to hold up at the same time. You're going to get the most dynamic range that it's possible to get out of your display, and you're going to get natural, vibrant colors to work with while you're editing your images. So this is a little schematic that I made up, and again, you're better off looking over here. You can see that the squares on the top, and I exaggerated this to make the point, the squares on the top are kind of faded, they're kind of off, they just don't look right, and the squares on the bottom are highly saturated, they're very vibrant, and that's a very good example of what happens when you calibrate a display for the first time. These things come out of the box, they're too bright and they're too blue. Now what does that mean? They're set up for word processing. I don't care if it's a Mac laptop or it's a really high-end video monitor. All of them are set up at the factory so that they show you red, green, and blue, and that's about it. They're not calibrated. And they need to be governed by a device like this to make them work properly. And this is the most sophisticated and accurate of these devices that we've made yet, and it will actually also calibrate your iPad and your iPhone. It's a 7-channel sensor. It will work with just about every type of LED and LCD display that's out there. It's calibrated to look at color the way your eye sees color. And so it's a natural result. And one of the things that I really like about it is I have a wide gamut display, and a few years back when I used one of these for the first time, one of the things I noticed is that the mid-tone transitions, particularly in a portrait, the transition of a shadow across a cheekbone, for example, was much smoother and gentler and much more natural looking. There was no pixelation across high contrast edges. That down in the grass you could see the shadows between the blades, and you could see the definition of the clouds in the sky. And I thought that, boy, I'd really gotten the most in performance out of that display that I'd ever gotten. Now, a lot of people say to me, this kind of thing is complicated. I hear that word a lot. It's complicated. It's not user-friendly. It's something I don't really feel like doing all the time. The fact is that you have to do this about once a month. You do it when you first get the display or you first get the calibration device. And the first screen that you're going to get in the software, which is very user-friendly, is going to be, what kind of display do you have? And you say, well, I have a laptop or I have a desktop, et cetera, et cetera. And you click OK, and you go to this screen. And it's really only going to ask you a few questions. It's going to ask you if you want to do a full calibration, you want to check your calibration, or you want to recalibrate it. Now, the full calibration takes a little bit more time. It's maybe 10 or 12 minutes to run through all those color patches and analyze them. And it's a little bit loud out there. The recalibration only takes a few minutes. It's going to go through just a selected few critical colors and analyze whether or not those are coming through okay. And that typically takes less time. And the check cal is simply a quality control check. Now, you can see here that these are drop-down menus. Each one of these has different values behind it. So the first one says gamma 2.2. Well, in the past, there were monitors that wanted to see a gamma of, say, 1.8 or less. Nowadays, it's better to just go with gamma 2.2. Just about any monitor made today will perform best at that level. The white point, the good white point, a place to start is 6500K. And then we got the issue of brightness, and this is the area that trips most people up. Most people work in a room that's too bright. I really want to encourage you to think about that. It's really nice to have a bright window with a view that you can look out when you get bored or you decide to take a break. But that bright window is not your friend. That window really needs to be covered, and the level of light in the room should be something halfway between what's available light up here and in the middle of the room where it's darker. So it's just light enough for you to move around the room without tripping over the furniture. Okay? And what's the reason for that? Because you want to get that screen brightness down. Screen brightness, when these things come out of the box, can be as high as 300 or more. Twice the brightness that's desirable for making prints or electronic, even electronic display. And so you want to bring that brightness down to about 120. I guarantee for the first week when you're at 120, it'll drive you crazy. Guarantee it. It'll take you a week to get used to it. But then you'll start to realize that you're really having a much better time seeing the values and the highlights and the shadows and things like that than you did when it was set to a brighter level. Those displays are set up for word processing when you buy them. They're not set up for you. And so they're really not photographer friendly. So the best thing I can say to you is give it a week, please. And you'll find that once you've got that calibrated, and we'll talk about getting your printer under control in a minute, but once you get that calibrated, you're going to find that it's a lot easier to get that screen to print match going. You're going to be doing a lot less of that print tweak nonsense. Now keep in mind, when you're doing print tweak, even an 8x10 costs you $1.50 at best. So you do 3 or 4 of those, and all of a sudden you're making a $10 8x10. That's not a great thing. That's just too much money for too much effort. What you really want to do is get it on the screen to the point where you make that print and you're ready to frame it. That's the ideal. And typically now, most people who have a calibrated workflow, they might make one proof print, usually for sharpness, because you can't see sharpness as well on the screen as you can in a print. And the rest of the time they are simply printing and framing, or printing and archiving. Now, one of the things that I like very much about this software is that there are some quality control and testing screens that are available that you can use to evaluate your results. This one in particular is showing us, you can see that big teardrop, that's the limit of human color vision. That's the engineering plot in 2 dimensions of what the eye, a normal eye, can see. And you can see that Adobe 98 is marked in purple. Adobe 98 being probably the most commonly used color space for pro-level editing that there is. Now, I have a wide gamut display, which is an HP 2480Z, which is on its last legs, by the way. It's 5 years old. And it still outperforms Adobe 98 probably by about 10%, particularly over here in the reds and sort of semi-magentas right in the middle there over to the reds. And so it's a slightly larger color space, but it's showing me after calibration what the range of color that's delivered by what the range of color delivered by the display is. Does that make sense? So it's a fundamental test of whether the display is functioning properly. And there's a lot of other tests that are available in here. I'm going to show you 1 or 2 of them just to give you an idea. There's quite a few. One of the tests is before and after, very simply. And we call this the spider-proof screen. And you can see down here, this is the before, okay? The before area. And then if you look on the lower left on that screen over there, that's after. Look at the difference in the colors that what I call reference colors. The green of the grass, okay? The blue in the sky around the church. Look at the difference, and particularly over here. It's much easier to see. And so you can see here that there's a difference not just in color, but in contrast as well. So you're getting a better gamma adjustment. And this screen's a little bit too bright, which I can tell, but you probably can't because the color is so good. But at the end of the day, you can switch back and forth and you can see the difference between what you had before and what you have now. Now, the first time you do that is going to be the most dramatic. You're going to see the biggest difference. Going forward, you'll see a smaller difference. And what's the reason for that? The display is going to change only a small amount because you're going to be doing this once a month. I typically do it on the 1st of the month. It's going to change a small amount. It doesn't matter what the display is. Light bulbs change over time, and at the end of the day, that's what's behind the screen that you're viewing is a fancy light bulb. And so they change a little bit over time, and you'll see a smaller difference. Now, most of these displays will last somewhere between 3 and 5 years. At some point, you won't be able to calibrate it. Then you'll know it's time for a new one. Oh, I forgot to mention, each one of these, the photographs in here are divided into sets. So each one of these is different types. So you have the black and whites, for example. If you double click on that set, it will enlarge like this has enlarged. And you can see it in a larger view. In other words, it will expand to fill that frame. If you click on one of the individual photos, it'll expand again. So you can go in and look at the details of any one of those test images. So we have some chili peppers, and we have beads, and we have the color checker chart on the upper left, some portraits. The black and white photos are particularly useful to see if you have any kind of color cast or tint remaining in your display after you've calibrated it. Some displays, unfortunately, are not going to you can't calibrate them to be perfectly neutral. It depends on the display and how it was made and how old it is. Now, this is a sort of a list of the tests that are available, and once you run them, the software will aggregate these into this table and give you an overall view of the display that you're using. One of the reasons this is useful is, let's say you have a 2-display setup. A lot of people have one display they use an older one for their palettes and their menus and their controls, and the other one to look at the images on. But you can test one against the other. You can calibrate them both and then test one against the other. And we've got tests for gamut and tone response. Luminance uniformity is one that's really important. That's the brightness corner to corner. Remember we talked about that Apple Cinema display that I didn't like from years back? That was a long time ago. Color uniformity is also another one. Color accuracy, et cetera, et cetera. Now I'm going to go on to another subject, and this is one of the tougher but more productive parts of the presentation. So we're going to talk about soft proofing. If there's one of the things that's important today, calibrate your display. Not everybody here is calibrating your display. I can't stress enough the importance of that. It's not that expensive. It will pay for itself in short order in terms of prints that don't work. You'll get rid of those. You'll be spending less time in front of the computer and more time behind the camera. The other thing is leverage some of the assets that you have in the software and use what I call live color preview or soft proofing in things like Lightroom or Photoshop. Now, soft proofing is an archaic term, I admit it. Soft proofing is a carryover from the days of the old 4-color press when they had these $5,000 CRTs and they would be putting together a Newsweek or Time magazine and they'd be looking at the color on screen and the screen would be adjusted so it would reflect the colors that came off the press. Well, nowadays you can set up your display once it's calibrated so that what you see on the screen is what your printer is going to give you. And whether it's a PSP, an off-site print service provider, or it's your own printer. How many people here actually own a photo printer? That's not bad. Okay, good. And then the rest of you are what, either just looking at them on the screen or sending them out? How many people actually send them out to be printed? Okay. What I'm going to teach you here is going to help you too. So it's not just for people that own printers. So if you're in Photoshop and you're looking at the menus on the screen, if you look at the top here, it says View and then it says Proof Setup. Now, God bless the engineers at Adobe. That's a term of art that just makes me mad because it doesn't really tell you what it's going to do. Proof Setup, and then you go to Custom and you get this, which has a totally different name that says Customized Proof Condition. This is all about soft proofing and getting a live color preview. And what you're going to do is you're going to go to Device to Simulate. You can see where the red arrow is pointing. And whenever you set up a printer and you load the printer software, the printer also loads paper profiles. Those paper profiles are designed to govern what the printer does and correct the colors to standard colors, just like you did with your display. It does that for the printer. Does that make sense? So those ICC profiles for the printer that govern the color, that the amount of ink and where it goes and what order it's put on the paper, that gives you really good green grass and really blue skies. Okay, that color profile can also be used to govern what the display is showing you. So on level 1, you're calibrating the display to give you accurate color. On level 2, you're using the printer profile to show you what the printer is going to deliver when you make a print. Soft proofing or live preview. Okay? So once you enable this and you click OK, what you see on the screen is what you're going to get from your machine. And each one of these paper profiles, you can have one for glossy paper, you can have one for luster paper, you can have one for flat matte or Brita paper, any of those papers. Every paper that printer manufacturer makes, that profile is loaded when you loaded the printer drivers. It's available to you, whether it's Windows or Mac. On top of this, I'm going to show you how you can make your own profiles for non-manufacturers papers that are just as good or better. But the idea here is that you get a soft preview, not on paper, that's where the word soft comes from. You can get a preview on here that's going to let you do your editing in real time. As you do your edits, you're going to see what change is going to be delivered to you when you make your print. You're not going to have to guess. You're not going to have to wait to make the print. You're going to see it in real time. That's powerful. That's what this is all about. From the time you picked up that camera and the spider cube and got all the way to the point where you're editing pictures, you've been governing that flow of color all the way along. And I think now you're beginning to see how those pieces drop into place and make life easy for you. So once you understand this, every time I open an image, I think, okay, I'm going to print this on luster paper. I go open this dialog box and I pick the paper that I'm going to print on, and now I'm editing for my destination. Now, if that's not cool, I don't know what is. I'm not going to make a print that looks funny. I'm going to be editing and knowing what the colors are going to look like. I'm going to know what kind of highlight and shadow detail the paper is going to be able to carry. It's all good stuff. So here's an example. You can see on the upper left, better yet over here, you can see this would be for glossy or luster. That's that same image. And on the lower right for a matte paper or a Baryta paper. And you can see that it's softer and it has a more painterly look to it. That the highlights in general tend to blend together and the blacks are not as black or rich. Do you see what I'm getting at? So when you're editing and you're going to be changing curves and levels and hue and saturation and those other things, you're going to behave differently with the glossy or luster paper than you would with the fine art of the matte paper, because you're going to know that that result's going to be different. You're not going to be trying to crank the blacks down all the way because you're never going to get the same look as you're going to get with the glossy paper. You're going to see that on the screen. Make sense? Sort of? Okay. In Lightroom, it's much simpler to do, and I used to tell people before Lightroom 4, I told people I didn't recommend it because it couldn't do soft proofing. I don't like shooting in the dark, so to speak. I don't like editing an image and going along and trying to guess what my result is going to be. I like soft proofing to be enabled from the moment I start editing. Now in Lightroom, if you press the S key, that will start soft. This is in the develop module. Or you check the soft proofing box and you tell it what kind of paper you're going to use, which is right here. I can't do this sideways. I'm just not talented enough. Right here, you tell it which paper you're going to use. Now on screen, when you do that, by the way, you'll see the histogram change, okay, to match what the paper is producing. Once you do that, you're going to have that on-screen preview again, just like you had in Photoshop. So it's going to use your display calibration as the foundation, and then it's going to layer on top of that it's the behavior of the printing device that you're going to use, the paper and ink combination, and it's going to give you a live preview of your result. So all this stuff is coming up to you're in the driver's seat. Now, very briefly, there's an application called Spider Gallery that you can use for the iPad and the iPhone. And it's a little bit like Voodoo. You need a local network that your devices are on, the iPad or the iPhone, and your laptop or desktop computer. And it basically runs through the same iteration is that it shows a series of color patches. The device reads them and measures the difference and makes corrections to the color that you see on the device. And it's very interesting, as good as the iPad is, and this is a mock-up to make the point. This is not what the screen really looks like when you're testing it. But if you look on the left, one of the first things I look at in a portrait is the eyes. And then look at them on the right, you can just see that there's much more dimensionality just to start. Okay, the color is generally better. There's better definition in the hair, not only in terms of the strands of the hair, but the shadows in between. So you've got better contrast, better color, better definition, better dimensionality. The color in the flowers from left to right is better. And you can see those color charts also show you significant differences. I use my iPad to show my customers my portfolio. So I want the best possible color. Okay, and that's the reason I use it. It's a nice add-on. It's a nice add-on. The iPad is great. This just makes it a little greater. Now let's talk about printing, because in one way or another, at least in my view, printing is the objective. That once you click the shutter, at some point, the better images you're going to make a print. And some of the questions that people ask is, why would you make a profile of the printer? There's an option in printing where you can say, for example, in Photoshop, let the printer manage its own color, because it has a little computer on board. But the big difference is that each printer is a little bit different when it comes out of the factory. Each printer is in a different place. It's in a different room with different humidity. I mean, just look at what it's like in here versus what it's like outside today. Okay, so that combination of air pollution, temperature, humidity, etc., how much the printer has been used, how worn the ink heads are, all of those things make a difference in how the printer handles color. Okay, and so it's better to use a profile for the printer. Now, printer manufacturers make profiles for their own papers. The third-party paper manufacturers make profiles, say, Moab makes a profile for the Entrada paper that's intended for use with the Epson 3880, just as an example. It's a good profile, but it's not custom made for your printer. And like I said, you can make those profiles and get them pretty close, but they're never quite customized to that printing condition and that particular machine. So just to give you an example, in fact, it's the same fellow I was talking before that has the problems with the lighting. Had a very expensive RIP, which is a printer management software, and he was using their profiles, and we went ahead and made a custom profile for his printer, and he had a picture of some aspens with very, very saturated yellow leaves in the fall. And before we made the profile, you couldn't really see the outlines of the leaves in the bright light, and afterwards you could see each leaf individually. So there is a significant benefit, a gain to be had from making your own profiles for your printer, if you're really serious about getting the most out of it. I went the wrong way. So Datacolor makes it a device. It also comes with its own software called Spider Print. And again, this is repeating a lot of the points. I made a lot of these, I got ahead of myself. There's a couple of printers that have calibration technology built in, but most don't. And so you're in a position where you have to either settle for a compromise or make a modest investment and get the most out of your printer paper combination. I think most of us in this room make a point of getting the best camera and lens we can afford, and then we buy the best printer we can afford. But a lot of people, when they get just up to that finish line, aren't willing to invest in that last step in getting the most out of the printer, and this is what I'm talking about. So remember that it's the same basic idea where, and this is the first level profiling, set of first level charts. You can see that there's a number of patches on here, and there's a different device. What does this say on here? It's the Spider Print. And it has a different sensor on it. This has a light emitter and a color sensor in it. And you read the color by passing it over the patches on here. And you go from left to right or right to left. And there's an easel that comes with it, but generally I don't find the need to use it. I actually find it's easier simply to slide this across the paper. Okay? And it reads each patch, and it does pretty much the same process as it does, say, with your display calibration. It's reading that patch and saying, I'm supposed to see color X, but I'm seeing color Y, so I'm going to make an adjustment. It's going to save all of that into a file called an ICC profile, and that ICC profile is a printer profile. It's about the chemistry between ink, paper, and the environment. And when you have an ICC profile that's custom made for your printer, generally speaking, you are going to see a better result. So we're getting towards the end of the color chain now. Now, what does that do for you? I just talked a little bit about the profile that I made for my colleague. In that particular instance, the thing that we saw was a great improvement in highlight detail. But it really manages that whole dynamic range from shadow detail to highlight detail. Also, again, mid-tone transitions, those can be important. It's also going to improve the general accuracy of the tones that you get, particularly in highly saturated areas. One of the benefits that you're going to see is it's going to preserve the details. So if you have a highly saturated, even a man-made color, a red or an orange or a yellow, and it's got detail in it, like a dress or a piece of clothing, you're generally going to see more of the detail of the fabric, and you're going to see more dimensionality and nuances in terms of how the fabric was made. It's going to make for a more lifelike and believable photograph. So I can't stress enough that if you really want to get the most out of your printing setup, calibrate the printer. You can even send these targets to an outside print service provider and ask them to print it, all you have to do is tell them to turn off color management and print it on, you know, the paper that they're going to use for your images. And then when you get this back, you can actually make your own soft-proofing profile. So there's a number of ways you can use this that are very beneficial to you. In fact, here's an example of how you would use it when you're printing. This is Photoshop's print screen. Let me look at this. This is CS5, okay? And so it's divided into those typical 3 panels. And on the right, you can see Photoshop manages colors. Now, it used to say application managed colors. God bless the engineers at Adobe. And then you go down to the printer file, and you're going to pick that printer profile that you're going to use for your printing. Now, one of the things I didn't mention before is that in this panel, whether you're in CS5 or CS6, you do get a very small soft-proofing panel. It's sort of your last chance to see what the color is going to look like before you send it to the printer. But all you have to do is just turn on that printer profile, change it from printer managed color. Remember, the printer has a very small brain. It's like the size of a pea. It's much better to use the big brain in your big computer to govern the color that goes to your printer. Use the profile to really dial it in and get the full range of what you've captured and worked on during your image editing. And then you send it to the printer. Okay? So the default on this is printer managed color. Keep that in mind. You won't be able, at least in CS5 and CS6, you won't even be able to turn on printer profile. Okay. And it's the same thing in the develop module, or the print module, excuse me, in Lightroom. You'll see these same controls. You'll see printer managed color, or Photoshop, or Lightroom managed color, or application managed color, and you'll see a drop down for the ICC profile. Questions? There's got to be questions. How many people have tried this? Ah. Now, I guarantee if you try this, the picture police will not come to your house. Okay. I really encourage you to give this a try. The profiles, if you're using manufacturer's paper, let's say you have an Epson printer and you have Epson Premium Luster, just try making a print when you get home. Go to this panel in Lightroom or in Photoshop, change it to Photoshop Managed Colors, and pick that, say, Epson Premium Luster, and send it to the printer and see what happens. And I'll bet that you'll see a difference. Now, I want to back up for a second. I want to point a couple of things out here, is that in the software, you can see a picture of the chart that you're going to use. You can pick different levels of patch sets, so you can have this high quality target, which is just 2 pages. If you're doing a lot of black and white, you can pick another set of charts that have a lot more gray squares in them that will give you a better black and white. So it's called plus grays. You can do the expert targets. The fact is that the difference between the basic and the expert targets isn't that great. It takes a lot longer. And unless you're doing something that's super color critical, I mean, unless I'm doing something that's super color critical, I don't ever bother with it. This gives incredibly good results. A lot of people will say, oh, you need 1,200 patches. You really don't. You really don't. This will get the job done. Questions? Okay. Now, printing and prints, you want to print in a user-friendly environment. I use this picture because it's a bad example. Okay. This photograph shows this gentleman working in a brightly lit room. We talked about that before. Okay. The light is going directly on his computer screen, which is obviously not calibrated. If you just look at it, it's as blue as can be. Right? Now, the one thing he does have going for him is he has a color-balanced light box for print viewing. So you can see that the print in the box looks way better than his screen does. So there isn't anything really right that's going on with this photo, except maybe that he's got a cup of coffee. So some printing tips, and then I'm going to talk a little bit about, I'm going to show you an example of some really nice printing. Use the manufacturer's inks when you're printing. It's really important. You want to use the best inkjet paper your budget allows. I know a bunch of people who will go to a budget big box store and buy the cheapest photo paper and then say, geez, I made a profile for it and it didn't work. Well, a lot of those cheap papers are cheap for a reason. If you're really, I mean, they're okay to practice on. Okay, I mean, you can use them for that, but if you really want a print that's going to last 100 years and give you the best color and the best detail, then spend the money. Seriously. Again, I'm going to emphasize, oh, by the way, and store the paper in a cool, dark, dry place. Under the bed is not the place to do that. I typically put them in the corner, a closet that's in the center of the house, on top of something else, off the floor, and it's in a plastic bag. So it keeps the bugs out, for one thing. What you want to have is some kind of daylight balanced light to view them. If you can't afford or don't want to invest in that, at least walk over to a window it's a shaded window, it doesn't have direct sunlight coming through it. That will give you a much better view of the print than, say, even one of these or the lights that are out in that room. All right? Let them dry about 24 hours, particularly the Epson prints. They outgas, they have a lot of solvents in them. If you frame them too early, you're going to see those gases condensing on the inside of the glass, and you'll see smears and droplets. You don't want to do that. So let them dry for 24 hours. Put a little bit of archival interleaving paper, that's really smooth interleaving paper. You can get it at an art store in between. You know, if you're handling them a lot, buy yourself a pair of those lint-free Mickey Mouse gloves. They have them here at B&H. Let's see. That's about it. So now, let's talk a little bit about showing your work. I thought would be a nice way to end the session. This is a picture taken again in the Palouse. The color over here is much better. This is an old farmhouse that's slowly settling into a sinking land. It's kind of an interesting spot. And what we've been working on is a portfolio that actually comes in a folder. This is very easy to make because it's an 8x10. It has a window in it so you can show a preview. And then the images inside are all printed 8x10 with an inscription. So he has a title page. And then he has a series of images. It's an ensemble on a topic. Okay. Or it could be a range of images based on your best work. And you can see that it's very nice and easy to handle. It's much more intimate than a book in a lot of ways because you have to handle each page individually. You can put your own inscription on it. And you can take an image out and substitute another one if you want to. So it's very flexible. These are all printed on the Ilford, I think they called it the Gallery Silk, which is a version of a Baryta paper. But you can get the idea that it's an ensemble. They all fit a theme. Okay, it's not expensive to do. These little folders can be purchased online for about $5, and of course, each one of these prints probably costs about $1.80. So it's a way to publish yourself without spending a lot of money. And it's very well controlled. This is a guy that I feel pretty proud of. I brought him along with his color management. He shoots a 4x5 U camera, and he shoots film. Typically shoots Fuji Ostia, and he has it scanned on a drum scanner, and then we do Photoshop editing and we print on his 3880. And he's implemented all the color steps that I've shown you, except for his doggone cabinet lights. So I don't particularly like that picture. Oh, this is beautiful. Can you see the color of the reds and how nice the subtleties come through?
Okay. The reflection from the light.
Yeah. So that's the kind of results you can get when you have a good color managed workflow. Now, I want to emphasize again that it actually took longer today to describe this than it would take most of you to implement it. The software is very user-friendly. There's a lot of commonality between the different modules. It's simply step by step. The device gets measured on the basis of standardized color exposure to different color patches. The software and the computer measure the difference X to Y between each one and calculate a set of corrections, and you apply them. Once you've done that and you've got it in your cycle, it's going to take you half an hour a month to implement all of this and to have it available to you as you work. So it becomes part of your habitual workflow. And you get that end-to-end color management, you know, from spider cube to printer profiling. You've really got it nailed, and now you're in the driver's seat. You can do pretty much whatever you want in terms of image editing and know immediately what you're going to get. So thank you for your attention. I hope you had a good time.
Thank you.
Thanks for coming.
Whether you're a hobbyist or a professional, B&H has the answers to your questions. Experience a world of technology at our New York City Superstore. Connect with us online or give us a call. Our staff of experts is happy to help.